Alright, if you're watching this video, it should be on Thursday, either during class or Wednesday night, the day before class. This lesson for 6D is for Thursday, and I'm going to go ahead and do all of the examples. There's only 3. To give you another formula, basically when lesson 6C was an arithmetic sequence, is where you just have a number, comma, another number, comma, another number, and it's just a series or a sequence of numbers. An arithmetic series is when you're actually adding up. You're finding the summation of those numbers. So it's the same process sort of, but you're just adding the numbers up. And they have a formula for that. They actually have 2 formulas depending on what you're given. Sorry for the loud, my cat is scratching up a box, I think. So formulas. The 2 formulas they give you in this lesson are SN, the sum of the first n terms. So it might be the sum of the first 3 terms, or the first 10 terms, or the first 100 terms. So that's what that means. The sum of the first n terms equals n divided by 2 times, in parentheses, the first term plus the nth term. So if it's the sum of the first 10 terms and you know the nth term, the 10th term is 60, then you would plug in a 60 right here. Oops. I did something. There we go. I'll do some examples. So this formula would be used if you know the first and last terms. The first and last terms. Okay, in that particular sequence. It's the only time you can use this. Now, if you don't know the first or last, the formula I just gave you is by far the easier one. But if you don't know the first and last, then you have no resort. But besides to use this other formula, which is definitely more annoying. It's 2 times the first term plus n minus 1. There's that n minus 1 again. Times the common difference. It's kind of annoying. And it gets even more annoying when n is an odd number, because you're going to have a decimal, and that's never fun. You'll see what I mean when we get there. The second formula can be used if you know the first term and the common difference. There you go. Okay, so let's just jump right into one of the examples. So you have to decide each time which formula you're going to use based on the situation that they give you. So worked example. (6.9). This is on page 142. And it says find the sum of, I'm trying to just shorthand it, the first 30 terms of an arithmetic progression. There's that word arithmetic progression again. The first term is 8 and common difference equals 0.5. Okay, so we know the common difference and the first term. Well, that means that we kind of have to use this formula, this long doozy of a formula. We don't know the last term. We know the first, but not the last, so we can't use that easier formula. So let's see. Always start with the formula. Let me see if I can remember it. The n, no, it's the brain sum. The sum of the first n terms equals n divided by 2 times 2 times the first term plus n minus 1 times the common difference. Start with the formula and then plug in. The sum of the first n terms, and that's what we don't know. It's the first 30 terms, so n is 30. That's nice, it's an even number, so we don't have to worry about a decimal. 2 times u1 is 8, plus, there's our n again, so you're going to see n twice in this formula. Yes, you will write it twice. Oops, we know the common difference. That's just 1/2. 0.5 is 1/2. Actually, that's not going to be fun because we have 30 minus 1 is 29. Oh, that's not going to be fun. Oh well. Can't have it all, I guess. So the sum of the first, actually, what I forgot to write is it should be the sum of the first 30 terms right there, not Sn. Sum of the first 30 terms is 15 times, in parentheses, 16 plus 29 times 1/2. Oh, it's going to be a decimal. I'm not even going to bother working it out by hand. Actually, the book didn't work anything out. They just get straight to the calculator, I guess. So it's 457.5. So the sum of the first, so therefore, I'll go ahead and write this. The sum of the first 30 terms is 457.5. You're probably wondering, how in the world is there a decimal? Let's look well, the reason why we have a decimal is because we're adding 0.5 each time. So every other number is going to be 0.5, basically. So we just happen to get one that happened to be the 0.5, so that's why. And there we go. So that was the first example. Not too bad. Just plug into the formula and simplify. We have 2 more examples. The next one is a little weird, so be ready. Worked example 6.10. Okay. Find the sum of all the multiples of 3 between 100 and 1000. Okay, wow. They don't give us a lot of information there. This is one of those think outside the box questions. And for SL, this is about as outside the box as they make you think, is something like this. It's not too bad. You should see the think outside the box questions in higher level. They're really some doozies, but this one's not too bad. You just got to think a little bit. Use your brain a little bit. It's not straightforward by any means. They don't give you first term or last term or even common difference. They don't give you any of that. So you kind of have to read in between the lines, really. So multiples of 3 between 100 and 1000. If you think about it, a lot of people would be like, okay, well that just means that U1 is 100, right? Well, no, you would be wrong. Because 100 is not a multiple of 3. So our sequence is really going to be 3, 6, 9, 12, 15, 18, 21, 24, and so on and so forth. So the only numbers in our sequence is going to be multiples of 3. 100 is not a multiple of 3, so it cannot be in our sequence, and it cannot be our first term. So then what is our first term? Well, I know 99 is divisible by 3. So therefore, if you add 3 to 99, it would be 102. So therefore, the first term would be 102. Can we use the same logic to find the last term? Sure we can. Our last term, un, is going to be 999 because 1000 is not divisible by 3, but 999 is. So it's between these two numbers. So it has to be, these two numbers, your first and last, have to be in between those two. So we have those. So it looks like we're going to be using that first formula, that easy one. I'm trying to make sure we have everything we need for that formula. Go to the previous page. We need the number of terms. I think we have that. Some of the first. No, we don't have that. We don't actually, we can find that though. I'm going to tell you in a second. We need to know how many terms there are. We don't know that, but we can find it. We already know the first and last term. U1 is 102. And your nth term, your last term, is going to be 999. But we're not ready to go quite yet because we don't know how many terms are between 102 and 1000. But we can find that out. The rule, in case you didn't know this, and this is a handy thing to know, if you ever wanted to find out how many numbers are in between two particular numbers, it's really simple. You just subtract the two of them and then add 1. Always, always, always. It works every single time. I promise. So let's test that out. How many numbers are in between, I don't know, just pick 2 random numbers. How many numbers are in between 21 and 6? How many numbers are in between 21 and 6? Well, you subtract, well, let's find something smaller. I don't want to count all that. How many numbers are in between 13 and 7? Okay, so let's see. You subtract the 2 and add 1, and you get 7. How many numbers are in between 7 and 13? Okay, well, so it's 7, 8, 9, 10, 11, 12, 13. There's 7 numbers in between those two numbers. In between 13 and 7 is 7 if you count 7, 8, 9, 10, 11, 12, 13. That's 7 numbers. And so you can test this with any two numbers if you would like to, but I promise you that to find how many numbers are in between two numbers, you subtract the 2 and add 1. That is the rule. So if we want to know how many terms are in this sequence that begins with this number and ends with this number, we would just subtract them. Okay, so my camera's just died. That's why you can obviously tell the different, that I moved the camera. So, and then I was having some problems. So, I had to move the camera around to get it to work. Okay, so now we're ready to go. Now we're trying to find the term number that goes with this. Oops, still have my eraser on. We're trying to find the term number that goes with this last term right here, because that will tell us how many terms we have in this sequence. So we're going to say 999. That's our nth term, equals U1, which is 102, plus, parentheses, n is what we're trying to find, and the common difference is 3, because we have multiples of 3, so therefore the common difference is 3. We have 897 equals 3n minus 3. 900 equals 3n, and so n equals 300. So that means there are 300 terms. In this sequence. It starts with 102 and ends with 999. We're still not done with the problem. You always have to keep asking yourself after you've done all this stuff, am I done with the problem? No, you're not. The whole goal of this problem was to find the sum of the multiples of 3 between 100 and 1,000. So we're still trying to find that. But fortunately, we're finally ready to do that. the sum of the first 300 terms is equal to, and it's the formula is, I'm trying to think of it. I have to look it up. It's not coming to me. It's not on this page. It was there it is. N over 2 times U1 plus UN. Let me write the formula first. So the sum of the first 300 terms is 300 divided by 2 times U1 is 102. Our nth term is our last term, that's 999. So the sum of the first 300 terms is equal to, let's get our calculator out at that point, 165,150. That is the sum of the first of, so therefore, the sum of the multiples of 3 between 102, no, not 102, 100, and 1000 is, this is a big number, 165,150. Who would have thought it? The sum of the numbers between the multiples, and that's just the multiples of 3, that's not even all the numbers. That's just the multiples of 3. The sum of the multiples of 3 between 100 and 1000 is 165,150. That's an awful lot. Who would have thought it was such a big sum? Anyway, so we do have one more example. That lesson's still not done. We have worked example 6.11. On page 143, oops, turn back. An arithmetic sequence has first term that's U1 is 5. Common difference is 10. If the sum of all the terms, sum of n terms basically, they didn't tell us how many terms, is 720. That looks like a 6. How many terms are in the sequence? So basically we're trying to find n. Okay, let's see. I think we're going to use that second formula. The second formula, I think we can use this one right here. See if I can remember it. Okay, so the sum of the first n terms, again, that's something we don't know, is going to be n over 2, again, that's what we're trying to find, times 2 times U1 plus n minus 1 times the common difference. Oh, but we do know Sn. Sn is 720. There we go. Okay, so now what we have to do is find n. We just have one variable. That's a good thing. That means we have enough information to move on. I am going to, oops, I forgot my parentheses. I'm going to multiply both sides by 2 to get rid of my fraction, because we don't like fractions. They're kind of in the way, make things difficult. Better just to get rid of them. So this is 1440 equals n times, and this is 10 plus 10n minus 10. Ooh, we're going to wind up with a quadratic. Fun. actually, the nice thing is that this cancels with that. That goes away. So we just wind up with 10n squared. Divide both sides by 10. Oh, but it's a nice quadratic, so that's not too bad. So n is equal to plus or minus 12. But since n represents the number of terms, you can't have a negative number of terms. So n equals negative 12 is rejected. The IB examiners like that word rejected. Therefore, n equals 12. There are 12 terms. Let's see if that was the question they asked, because I forget what they asked. How many terms are in the sequence? There we go. Okay, so we did answer the question. So therefore, there are 12 terms in the sequence. And that's our answer. There are 12 terms in the sequence. Okay, that is it for exercise lesson 60. You're going to now work on exercise 6D that will be due after Christmas break. Obviously, tomorrow is no school, no class. Well, I'm sorry, no class, no regular classes anyway. You will not be attending math class. We were supposed to do 6E, so we have a little bit of a problem. I don't know if I'm going to assign that just yet. We may have to figure out how to catch up in the new year at some point. So just for now, try to finish up 6C and 6D before Christmas break, and then try to enjoy your Christmas break, and we'll come back after the break. And I may have already told you, I don't know, I'm doing this video on the Wednesday before I go on my leave, so I don't know yet, but I may have already told you what we're planning on doing with lesson 6E. Somehow we're going to have to catch up on that. We may do that in the new year somehow. I don't want to overwhelm you too much. That means you'll have to complete the lesson and exercise and everything over the break, and I hate to make you do that. So anyway, we'll figure it out later. But for right now, I need you to just focus on completing exercises 6C and 6D. When we come back in January, make sure those are due. I think we come back on the 4th or something. 5th, I think. We don't have class on Tuesday, so maybe like the 6th or something, I think. So make sure those are done. Don't wait until January 5th to do it, because you probably won't remember anything. I guess you can go back and watch the videos, so not a huge deal, but anyway, better just to get it out of the way and get it done. And be prepared to start lesson 6E when we come back in January. Alright? Well, you have a very Merry Christmas, and I will see you when we come back in January.